Okay, welcome back. I think we got these tech difficulties dealt with. So, we covered this cool interaction matrix in the last mini lecture where we have negative 0 plus, negative 0 plus, and we said we're talking specifically about these interactions here, right? That have a net positive impact on one of the species and a net negative impact on the other. And we said that these are called consumer resource interactions. We talked about various cases of those. And in this mini lecture, we're going to compare and contrast carnivory and herbivory, right? Carnivory and herbivory. We're going to leave out omnivores here. These are animals that eat both plants and animals, but really we're talking about the interaction here, the interaction itself, and each interaction is either carnivorous or herbivorous, right? When I'm eating a steak, I am making a carnivorous interaction. When I'm eating my kale salad next to it, I'm doing an herbivorous interaction, right? Okay, so carnivory and herbivory are fundamentally different, right? We said that carnivory is an animal Pac-Manning another animal, eating another animal. And these interactions, first of all, tend to be generalized. I might say that carnivores tend to be generalists, right? They tend to be generalists, meaning that a given carnivore can eat many species of prey, right? Typically, carnivory is driven by abundance of prey, right? So it's driven by encounter rates, your likelihood of running into a prey. That doesn't mean that some carnivores don't have preferences, right? And we can define preference specifically as the relative consumption of a given resource compared to its encounter rate in the landscape, right? So if you wanted to ask whether or not I have a preference for hot dogs, right? Whether I have a preference for hot dogs. I'm a generalist carnivore. I eat steaks and I eat lamb and I eat fish. But do I prefer hot dogs? What you would do is you'd say, okay, how often does Jake run into hot dogs, right? And does the percentage of hot dogs in his diet outweigh the encounter rate? If every 1 in 10 pieces of meat I encounter is a hot dog, but every 5 out of 10 pieces of meat I eat is a hot dog, that means I'm preferentially eating hot dogs, right? That's a weird example, but driven maybe by Tim What's-His-Face from I Think You Should Leave. But preference. So preference is the relative consumption compared to availability, right? And if that number is high, if you consume more than is available, you have a high preference, and you are less generalized, right? More specialized. And at some point, you might run into someone who only eats hot dogs, right? Even though they could eat steaks and lamb and fish and whatever, they only eat hot dogs. When that preference equals 1, that organism is totally specialized, right? If that preference is greater than, or sorry, this is, if that's greater than 1, for example, right? Like if 100% of their diet is made up of hot dogs, and hot dogs are a very small portion of what's available, then they're specialized, right? But that doesn't have to be an all or nothing thing, right? Like specialization to generalization, this is an important idea, is a spectrum, right? We're going to leave a space for herbivory here, but we can think about specialization to generalization as a spectrum, right? And that at the far ends of the spectrum, total specialists, that means they're eating 100% of one thing, even though the encounter rate is not 100% of that thing. And total generalists are just eating given to the encounter rate, right? They'll eat anything they encounter. But that doesn't mean you have to be one or the other of those. You can be somewhere on this spectrum, right? You can eat a few more hot dogs than you might encounter. Or just a little tiny bit more hot dogs than you encounter. You're still more specialized than someone who only eats exactly how many hot dogs there are in the environment. Why am I stuck on the hot dogs thing? It's late. I have eaten dinner. We had peanut butter and jelly sandwiches, not hot dogs. But here we are, right? And so this more or less specialized is how I want you to think of generalization and specialization. Not as a categorical, either you're a specialist or you're a generalist, but rather some species are more specialized than others, right? Some interactions are more specialized than others. Some are more generalized than others. Think of these as continua, right? Okay, so that's carnivory. Tends to be generalist. There is differences in preference among carnivores, but we can tell that preference given the amount of given resource that is consumed relative to its encounter rate in the landscape, right? Alternatively, herbivory interactions. Herbivory are where an animal eats a plant. I guess this could be a plant. We didn't talk about carnivorous plants, but there are plants that eat animals. But anyway, herbivorous interactions are where an animal eats a plant. These tend to be more specialized. Right? These tend to be more specialized. That doesn't mean they're 100% specialist. That doesn't mean that every species of animal that eats plants only eats one species of plants, but rather that animals that tend to eat plants tend to be more specialized, right? Most herbivores usually specialize on a species. A lot of herbivores specialize on a specific tissue, right? So we learned about this with the Graia moths and the Lithophragma and the geographic mosaic of coevolution, right? Where the larvae of the Graia moths are specialists on a specific tissue, not just on Lithophragma, not just on a specific species, but they specifically eat the seeds, right? The ovules before they become seeds. And these herbivory interactions tend to be more specialized, right? They tend to specialize on specific tissues. They tend to specialize on specific species. And this can largely be driven, some of the ideas that drive this are things like plant defensive chemistry, right? So animals can defend themselves in a lot of different ways, right? Animals defend themselves in lots of different ways. They can be really good at running away. They can have camouflage. They can have big sharp teeth to defend themselves, right? They can also defend themselves chemically, right? A great example of this are salamanders and newts from California, right? That have these tetrodotoxins. These are crazy specialized toxins. They're neurotoxins. And there's all these like historical stories of miners out in California scooping up water from a vernal pool and getting a newt in it and making their coffee, and then they die, right? Some of these animals that are eaten by carnivores have crazy high levels of toxins. Some of these newts have enough toxins to kill hundreds of adults, right? And in that case, we have a highly specialized carnivore that eats them, in this case garter snakes, that have co-evolved with them to have really high resistance to these tetrodotoxins. They can eat levels of tetrodotoxins that would kill any human. The same is true of plants, right? Plants, one of the main ways they defend themselves is via these crazy specialized metabolites, things that are highly toxic to you and me, things like caffeine, that if we had enough caffeine, we'd die. Like morphine, if we had enough morphine, we'd overdose and die, right? These specialized metabolites, these toxins, take all kinds of wild biomachinery inside the consumer to be able to consume, right? It takes a special kind of biomechanics, a special kind of biochemistry, for example, for a monarch caterpillar to eat a milkweed plant, because it has these specialized cardenolides that are highly toxic to all kinds of predators, right? That are highly toxic to all kinds of herbivores. And these defenses are what cause more special, or one of the hypotheses about why there's so much specialization in herbivory is because of these defenses, right? That these defenses help drive specialized interactions among herbivores and plants. And again, we can measure preference here, right? In the same way, relative consumption of a given resource versus another. But what you should really know for that section, for this is like, concept 12.1, 12.2, right, in your book, is that I want you to think of specialization and generalization as a spectrum, where some interactions are more or less specialized, more or less generalized, but not a dichotomous categorical variable. And that in general, herbivory tends to be more specialized. This tends to be driven by crazy chemical defenses or physical defenses of the plants that animals have to then evolve to overcome. And that coevolution comes with costs of being able to eat other things, right? It comes with costs of not being able to, for example, eat a broad diet, and rather you've invested evolutionarily as a species all of your biochemical pathways in handling these defenses. And that is one of the ideas that drives specialization in herbivory. That's also something that drives specialization in carnivory, in this case of newts and coevolution with garter snakes. So you should know that example too, because it's such a cool one. And in fact, I'll probably do a case study of that one for this week. Okay, that is carnivory versus herbivory. Sweet.